Hi, I'm Yiwei, a PhD student in the ID lab of Ghent University. Today I'm going to talk about my project, CookBot, a conversational agent to support procedural tasks. In our project, we want to build a conversational system that can extract information from unstructured text to compose its responses and give guidance to the user's actions. More specifically, we focus on procedural documents, which are quite prevalent in our life, like the cooking recipes, chemical processes, and mechanical manuals. In our case, we take the cooking recipes as a proof of concept. So the first step is to extract key information from unstructured recipes, which we call the procedural knowledge. Then combined with machine learning models, we can build a conversational assistant. This assistant will instruct the user to accomplish the cooking process step by step. And finally, the user will get his or her desired dish. But before we start to design such a dialogue system, there is an important prerequisite. That is to enable the conversational assistant to understand the procedures. The first step we take is to build an automatic parsing system of the procedural documents that can identify the entities such as ingredients, temperature, or tools, as well as the actions performed on these entities. This is discussed in more details in our first publication. The main takeaway here is that we already built a procedural document dataset and the baseline models that can achieve such automatic information extraction. So now back to our dialogue system. The CookBot is actually a pipeline system composed of 3 steps. In the right part, you can see another recipe, and for each ingredient and instruction, we assign a unique identifier, which will be used in our dialogue annotations. In the left part, there is a dialogue example. So for each user question, the first step is to parse the question into a semantic frame, including the user intents, completed step, and the requested step. These 2 steps actually comes from the recipe annotation in the right part. And the second step is to use another model to predict the agent action frame, which is an abstractive representation of the agent's reply to the user's question. Now, with the help of this action frame, we employ pre-trained generative models such as T5 or BART to generate natural responses. All right, let's have some fun playing with our CookBot. In this dialog window, there are already several turns between me and the bot. I first ask about the recipe name, and then this bot instructs me to preheat the grill and prepare a bowl. Then he also told me to add 4 ingredients into the bowl. But apparently he made a mistake here, as he told me 4 ingredients to add, but actually there are 5 ingredients in the recipe, I think. This is due to a limitation of our current model, because it lacks ability to do a reasoning over the recipe information. But anyway, let's continue to play. All right. What shall I do now? Good. Next. Now he's telling me to cook the burgers to desired doneness. How long? This question is a bit hard because I may ask about the time of the oiling preheated grill instead of cooking the burgers, but he seems to understand my question. You should cook to an internal temperature. All right, I think I like this answer, and this is a demo part. Let's get back to the slides. So in this project, our main contributions include a new dialog dataset and 3 baseline models. As we see from the demo plane, the pipeline setting of the CookBot makes the generated responses natural enough to engage the user into the conversation. However, as I mentioned, there is still a large room for the improvement in terms of the reasoning ability, like numerical computation and multi-step reasoning over the long dialogue context. We also found that the CookBot doesn't have a good performance in coreference resolution, so we still have a lot of work to do. So that's it. If you have any question, just let me know. Thanks.